Hello, and welcome to another compiler demo. Today is the third compiler demo, and if you've not watched the others, please go watch them. They're on my YouTube channel, which is on Ginger Games it is, and it's on the compiler demo playlist. I'll link to it probably in this video where it pops up, or my Twitter page, or whatever. So today I've got a lot to talk about. I've got kind of 5 or 6 topics to talk about, which is quite a lot. And hopefully I won't make this go on for too long. So this is it. Some new brand spanking features in the compiler and how I'm going to do it. So let's talk about the very, very first one, which is this procedure. I'm going to call that. And hey presto, that ran and did nothing. There we go. It wasn't very exciting now, was it? So what this is structPadding. So this is the topic. So here are 2 structures, right? A and B. Inside of them, they have they've got a U8, a U32, and a U16. So they've got an A, and that's whatever. And then a B here's got a 7 of U8, array 3 of a U16, a U8, and a U16, whatever in there. Now, when we print the size of them, we get is the size of it is 7 and 16. Now, if you were to calculate this manually on paper, you'd be thinking, wait a minute, that doesn't add up. Because what you'd be expecting for the first one is this: you've got a byte, which has got an alignment of 1, but this has got an alignment of 4. So you'd have some padding, 3 extra bytes of padding. And that's okay, that would be weird. So you've got 3 extra bytes, that's 4. This has got this fine, so that's 4, plus another 2, so this should be 10 bytes. What's going on? I'm getting 3. What's gone wrong here? What about this B1 here? So let's count this again. We've got 7. This should be 8 bytes. This should be 6. Yeah, that should be 6. Plus 1. Plus another 1. Plus that. So that should be 18. But we're getting 16, it says. So what's going on here? Well, what I'm doing now, by default, is I'm rearranging the members within a structure, or records, a structure technically, so that you get the minimal alignment padding as possible in average cases. So there's a little article by Charles Bloom, and I completely agree with him up to about the 3rd paragraph. Which is, he was saying here, structs are not what you want. You kind of want a struct to you, or to me, it's actually a bundle of data that I want to bundle together. I don't care what order it's in, just rearrange it for whatever reason. It says put all these values in the thing, and I don't care what order. It says, get Misc compiler, put these orders and optimize for minimize size or speed or whatever. Then he talks about his kind of like, it's like goes interfaces, but for data rather than functions. And I don't really like this idea, because I think it's a little bit complicated to conceptually have. And also I don't really see the benefits of it, really. And I prefer my using thing, which is like import a namespace and do it that way. For me, that's much easier to conceptualize, and also way more useful. So he just sorts that, but I do agree with him with this bit here. So I was talking with Sean Barrett about a week ago about this, and I was asking him, how do you think would you do the algorithms? He kind of said just range by like biggest to smallest size. I kind of figured out the best algorithm, which is to do biggest alignment to biggest alignment, and to smallest alignment. Then if the alignment's the same, then go from biggest size to smallest size. And if the size is the same, then just do what the original source order is. Now, if you want the original C ordering, like it does this ordering and adds the padding, then what you can do is write ordered next to it. There's a tag on the struct, and you'll get the ordering. So it's against 10 bytes and 18 bytes. So this is with your C style. Now, this is needed for when you need to be interfacing with C, which depend on certain data structures, which need to be ordered correctly. Again, this is very useful. And if you want to just do that, say, I want the ordering to be this specific way, because I want to be able to have like a V table at the start, and I want to be able to use those things correctly and easily just cast to it or whatever, you may want that. I'd prefer you doing the using thing, but it doesn't matter. Then if you want it to be packed, like you want to say, hey, don't care about alignment requirements, just ignore them, pack them as in the ordered, but pack them without any alignment padding. You can do that as well. Now this is very useful if you want to describe a binary format, again, images or video or even just your own custom ones, because you want to be extremely explicit about the padding and you want it to be portable as well. And you can see here it's the same padding as my rearranged version, but the ordering is kept. So this is the thing here. So this ordering here, my unarranged thing, is actually the equivalent to this ordered version here. So you can see how it's actually rearranged them in the order. So you can see here this has gone to alignment and size thing, and this one's here sizes, alignment first, then sizes. That's what it's done. Very good. So that's the simple thing. Let's go on to the next simple thing, which is balance checking. So before this, I already had compile time balance checking, and what that is let's say you have these two things here, and you've got, if you write an array and you write -1, which is this is a constant, this is a number literal, it'll say index -1 cannot be negative. This is the new Sublime Text feature. I don't know if I like it or not. I'll probably get used to it. It's also in your face, but it says, hey, you can't do this. You can't have a negative value. Okay, so that's great. So let's look at the number 4 instead. This one's out of range. The range is from 0 to 4, exclusive. I may have to change the things, but yeah. So that's out of range. That's the compile time stuff. So the question is, what happens if you can't do it at compile time? So let's do some runtime code. So we store these numbers as variables on the stack, and then pass them to here. So let's run that. It will get a crash straight away saying, hey, index -1 is out of bounds of range here. So let's just close this program. So that's the same. Let's go down here again and does the same thing. Index 4 is out of rounds range. So it tells me what the index is as well. It's great. So runtimes work. So we've got bounds checking on by default. So this works on arrays, it works on slices, strings, any of the procedures or operations that relate to them, like the slicing expressions or the new slice or the slice putter, and those stuff. They all work fine. Now the real question is, a lot of this, so if you're doing very high performance code, you sometimes just want to turn it off. Or you may want to do some unsafe stuff. You may want to turn it off in places. So I'm allowing this with like these, I'm calling them state flags or state tags. And the first one is no bounds check. That's all you write. And what you do is you apply this to the beginning of any statement, and I mean any statement. So if you run this code here, A in this case is -1. So I'm doing a base here, so I know the memory is valid. So doing 10, slice it between 2 and 6. So now it's only got 4 elements in it. And then I'm going to go, actually, I want to go to the -1th entry. So that's all I'm doing here with the A's. And actually, I want to store it to 0. So that works. Now I could apply the bounds check, and you can see it's being disabled. I could get rid of that bounds check, so do that. And then there's a crash here, just like an assert. That's all it is. Like, oh, it's out of bounds. Now it runs. So that's turn it on again. It works. So if I turn it on, just this statement here, which is an assignment statement, you'll get a bounds check and say, that's wrong. The range was from 0 to 4. I got 6. So that was good and dandy. And again, any statement, so I can apply it to an if statement, and this entire if statement would be checked. So this would be the same as me writing it here, but I think it's a little bit easier to read if it's on that line there. So this whole statement's now going to be checked and do whatever. So it's very easy. You can just toggle it on and off. It's on by default at the moment. But you can just turn it off even on a procedure level. So I can have this array bounds check on the procedure bit here, and now nothing in this code here has got any procedure bounds checking done. Or I could be very explicit and actually say, no, I actually want there to be bounds checking on this, whatever. But there you go. Lovely, isn't it? And I think it's very useful to have, because a lot of my bugs were going this way. When I was actually implementing this, the way I was outputting is I was using my printing function, and I was getting a crash, like I was getting a stack overflow, like what's going on here? Turned out I actually had a array bounds overflow, overflow in a sense that's out of range in my printing function, which then was calling the array bounds check, which was trying to call the printing function. It was like, whoops. it was some old, it's just literally C code I kind of transliterated. And it would have been valid in C because C has null terminated strings, so there's actually an extra value. In mine, I don't have null terminated strings, which is the sane approach, so it didn't work. So yeah, it was an off by one thing, but that doesn't matter. So there's array bounds checking for you. Very, very simple. They're the simple things. Let's go and start doing the crazy things. So there's all this crazy thing that's going on here. Let's go. It's called type introspection. So what I would love in a lot of programming languages, many of them do have this, but it's sometimes a lot of performance cost, or it's not easy to use, or it's not always what you want, in a sense. But I usually want to get the information on a type. The compiler knows it all. Why can't I get the information is my question. So I've implemented that. I haven't updated syntax highlight, who cares? So at the moment here, I've got two built-in procedures, type info and type info val. One's for specifying a type, another specifying value. I'm thinking I might merge them to be the same thing, but I did have them that, but I thought the syntax was maybe a bit confusing because I've got size of and size of val, so I thought of making it a bit explicit. I don't know, whatever. So this is here, we're going to type information, and what this does is it returns a pointer to the type information. All it does. And what this type of information is actually stored as a union. So if I go into runtime, here is the definition of a type info. So as you can see, it's a union. These are nested types, so they're not actually the actual things. Here are the actual different types you can have. You can have name types, integer, float, string, boolean, a pointer, a procedure, an array, a slice, vector, tuples. They're in procedures. That's how I store them internally. So I thought, why not? Structures, unions, raw unions, and enums. So they are all the type information. You've got all the data you need to actually generate all the stuff you need as well. So that's what it does. So that gets the type info for an int, and that'll get the type info for an int as well, but it's through a value. So what it's going to do here, we're going to pass info through, which should be an int, and we're going to go to this case here, and I should get, yes, it's an integer. So if I change this now to be a f32, it says it's a float. Let's change this to be a boolean. We get it's potato. There we go. Default is potato. Because who doesn't like potatoes? Now, if you know the type, again, with every union, you can do an unsafe cast, because that's how unions work. You can cast one pointer to another pointer, because how memory is stored. That's how a union works. So that's the unsafe cast. But if you want it to be safe, please prefer match type, because it'll be safe, type safe. But I'm not going to stop you doing unsafe things if you want. So let's go for a little bit more complicated values. So this is vector 2 and vector 3. So these are structures. Let's get the type information for each of these. So v1's a vector 2, v2 is a vector 3, and v3 is a vector 3. We'll get the type information of these, so t1, t2, and t3. I'm going to get rid of that. That's in the old demo code. I don't need that more. So I'm going to do a print line here, and then I'm going to do a print. So type of v1 is, and it says vector 2. Oh, so it knew what the name of the type was. That's nice, isn't it? Let's go here. Type of v2 is vector 3. So it figured out the type. Absolutely lovely. And actually, I can do this now, can't I? I don't need that in the old code. There we go. Lovely jubbly. So let's do this here. We can even compare the pointers, because each type info is actually unique. So the type information from the same types will work. So if you have, let's say, I'm just trying to think this out now. Let's say you have T1 and T2. So these are two different types, vector 2 and vector 2. It'll be a fault. It'll say it's false. It's not actually the case, which is what I expect. But these two should be the same. So if I compare the pointers to each of them, they should be true. And it says it's true. So the type information is already very useful for me, and I'm using it a lot of places. Let's get on to the next part where it's very important and why it's very useful to have. So let's go back to the demo, take away the type introspection and go to the any type. Let's print this. So that's some weird thing I wrote just as a test. So the any type is a very, very special type. Here it goes, any type, there it is. And what this means is an any type, you can implicitly cast to an any type. That's what you can. So here's some variables. Here's an integer. here's a floating point number, and here's a string. Store them as X, Y, and Z. If you want to be explicit, you could write here's an int, here's an F64, and there's a string. If you wanted to be explicit, I'll just, if you very much wanted to be. Yeah, it's still the same code. Now, all these types can be implicitly cast to any. So this is now, this X is now going to an int, an any int, an F64 is going to an any, a string is going to any, and an any is going to an any. Now, an any is a little weird that it's kind of the identity type. It doesn't actually get converted because it is already that type. And that's quite nice. And again, you can pass literals as well in there. And the reason, so I'll explain how this works. An any is kind of a structure. I do not expose it as a structure, like it's not in the runtime library, but it is a structure internally. Sometimes a slice is a structure internally, or a string is a structure internally. What are we doing for time? We've got loads of time. Yeah. So that's kind of very useful. So inside of an any type, you have two fields. You've got a data field and the type info field. The data field is a raw pointer to the data. Now the reason why, and that means it's a raw pointer, so like a void star in C. The reason why it's that is because I can't do a copy and there could be any type. So this size, the size of the type could be a byte, could be 10 bytes, it could be 1,000 bytes, 1,000,000 bytes. Well, it wouldn't be a million, you know what I mean? Like it could be a really big number. So you don't want to take an extra copy if you have to. And the pointer, the type info bit here, is a pointer to type info type. Now someone's asked, is anything like this auto? No, this isn't auto. Any type is actually a very special. It stores a pointer to the original data and the type information for the actual type of the data. And this is very useful for printf. So we're printing out the X, Y, and Z here, and we're getting that. Now we're going to look at how printf is actually implemented. It's going to the fumpt package. Again, I nicked the name from Go, who cares? And look at here. So we've got fprintf, print lines, whatever. So let's look in here. So we've got our variadic procedure. So variadics from the last demo, I've now implemented them for any's. So if we apply a variadic any to the args, and now we're going to expand all the arguments of args to the b print, which is a buffered print. So we're going to need to go to b print. We go to this one here. Actually, we go to the print line version. What you can do is you're going to integrate across all of the arguments. So args.count. I've changed it from being like len and cap. I've gone to being them .count now. I think I just prefer it slightly more because I like writing count rather than len, and I like writing capacity rather than cap. I know it sounds daft. It's one of those stuff. So that's kind of it. So we're iterating across them. We're going to print any to a buffer. So the buffer is just a pointer to a byte array. That's a byte slice. That's all it is. So let's go to any to buffer. Now what you do is got this lovely match type statement here, and I got it using here, so I don't have to keep writing it everywhere. And I can go through here. So I've got all the type information I need. You can see here's any types here. So we're getting the casting of it here. So we got the sign information for that integer, the size as well in bytes. Again here, the floats and stuff and the strings. So I've been able to actually get it from here and actually create a type safe printf or a print line function. You cannot do this in C. In C, you have to specify like %s, say this is a string. And if it's not a string, oh, whoops, you've cocked up. There's so many times I've done that and I make those sort of bugs because I'm rearranging elements and I forget to change it. And this is now completely type safe. Now some people, C++ fanatics out there say, yeah, but I could have just used the IO streams and overloaded the shift operator, the bit shift. I'm like, no, that's silly. And this is kind of like, you still got a procedure, not overloading anything, and it works, and it's complete type safe, and everything works. There was a bug I was doing earlier, and it was just I cocked up the type information stuff, so for some reason it thought booleans were structures, and I was reading wrong memory. Whoops. It didn't matter. It was an easy fix. I had like one line to add. That was it. I made a bug. So that's kind of any type, and it's very, very useful. Again, so now you've seen how an any works, and you know how some of the type info works. let's actually show it in action and show some very, very basic examples. So let's go to crazy introspection. So that's some stuff printing off here. Now that I've got introspection built in, I thought as well, on like a whim, I thought this is a very useful thing to have, and I want this usually all the time, as I want to be able to convert an enum to a string. This is something I usually want, and this is how it works. This is a built-in procedure, so it allows any enum. When I have like parametric polymorphism, I should be able to not even have these built in. There's a lot of procedures I won't have to have built in because you can implement them. But for now, they need to be built in. So here's a string I'm going to store to, and enum's a string. Is you got fruit.peach, and when you print this, it returns peach. So it's actually got the string. Great, that is. As I wanted. Here's another one. So this has actually got a constant expression. So this is done at kind of compile time. It's figured it out what it is. So this is actually a constant string. This is. This bit here, though, is stored in runtime. So it's calculated at runtime. So we go and store this on the stack, then calculate the enum to string, and it prints out as grape. It's great. Now, we could even just bypass this enum to string and just pass it straight to printf, and my printn line function already takes this into account. So I can just print out an enum and actually know the name of it. If I want this as an integer, I can just cast as an int and then get the integer value. Well, I should. That didn't work in that case. Whoops. And I've got another bug here. Just quickly fix it. None of you saw that. And I think that's a bug. Yeah, it's a bug. That should have worked. I'm casting it as an int, and it's not. Oh well. Should have worked, don't matter. There's a bug. That's probably not that difficult to fix either. It's probably like one line, come to think of it. So, we can look at how this is actually implemented, and I've done a really naive thing, but it works, and I don't really care. I think this is probably going to help forever. This is how you implement these are also the built-in procedures for bounds checking and stuff. So I pass the file, string, the column, the index, and the count, and it does all the calculations that I need. This is how my bounds checking works. So for bounds checks, slices, expressions, substrings, they all work. So this is how I do enums. I pass the type information and the value. Now the biggest integer size is 64 bits. So that's what I allow. So it doesn't matter, even if it overflows, integers are 2's complement, so it doesn't matter. So this could be U64 in the compiler, it doesn't really make a difference here. So what I do is I get the information here, and then do a safe type match here. Say, is it an enum? Yeah. And then we do a linear search through it, check for the values and the names. Because if we look at the type information for an enum, I store the base type information, so which integer type is it? Is it an int, an i32? Because you can be explicit about that. And type int here, or an i32 or a u32 if you want a particular size. Whatever, you can specify what the values are and the names. Very useful. These are just the strings for these things. So you could theoretically print out the full version of this because you know what the parent type is. So I can print out the parent type, and you know what, and you can just print a dot and then the base type. So even better. So that's the basic thing here. So now it's going for a little bit crazier, and some of you may already see why this is going to be really useful. So now this is a very unsafe thing. What I've got here. So what I've got here is the same enum type. It's a different one in a different scope, but it's the same kind of layout. And what I'm doing is getting the type information for it here. I'm going to do a very unsafe cast to a named type because I know this is named. It's not anonymous. Like, if that's anonymous, it's got no name. Well, it's assigned to a name already. So I need to get the name, and I get the name, so it's got dot name, so it'll be fruit. That's what the string will be. And then what I'm going to do is get the base type of this, so strip off the nameness of it. So if you go to a name type, the baseness is just the base info, and I just do this. Technically, this loop should only execute once, but that's just in case. It's just like a sanity check. That's how type info base works. And I know it should be an enum, so I'm going to do an unsafe cast here. Please, I'd rather want to use a type match expression. really, but I already know what the data is. And now what I'm going to do is I'm going to do a printf. See with these percents here, these are the values here. I could be explicit in their ordering, like do %0, %1. I could swap them around with %0 and %1, %0, whatever, it doesn't matter. And do that. So now it prints out the name. So you can see here is fruit, the enum, and the base type, which is an int. And then I'm going to print out every single enum structure here with their values internally stored, and then close it. So what I've done is, I've been able to generate the entirety of the data type from its own code. So I'm able to actually output the code. I can even do this for serialization. This would be great for serialization. So I've got a type, and it knows the data I'm storing, and I know the data layout. I can just store this out as text. It's great for metaprogramming. And that's, many languages can't do this very well either. It's like C++ with its type info can't do it. I know like some others can, but it's great. One other thing I should also mention is that the type information only gets created for the types that it needs it for. So it doesn't get created for all the types. I didn't want to be wasteful. I only create it for the types that use it. If that makes any sense. So yeah, that's great. So let's go even a bit further, and let's look at this print vector3. So vector3 here we got is x, y, and z, and f34. Let's create two variables called a and b, and we're going to store the values here. So x equals 1, y equals 4, and z equals 9, and do it that way. And that's quite nice. I'm going to print them, and we print them. You can notice it's actually printed out the data structure with the elements in it. Now, that's really, really useful for debugging purposes, because a lot of times I don't want to always go into the debugger and do stuff. I just want to print out this type and just say, can you print out the data structure with all the values in? Or even, this is just great for serialization. I've actually got the name of the type and all the data values and all the values it could be already stored in there, and they're all named. So I could actually input this code. By the way, this is still valid code, and it will still print out the exact same thing. And this all works in print line. It's all possible for you. So I'm going to print out a named type. It checks to see if it's a structure. The base type is, and then I just go print the name, print some curly braces, and then get all the fields. Now each field in a record, which is the technical term for it, it's a generalization of all like things that have members. Is it packed or ordered or whatever? So you can generate it if you want to be that way. And here is the stuff. So I have to store the name of the member, its type information for that member as well, and then the offset in bytes. So I'm actually able to know the size of each type info and then offset it again. So this is already great for me. One thing I haven't done yet, and this is an oversight really, I haven't stored the size of the record and its alignment. So I should probably put that in here. It shouldn't be hard to add. It'd be like a 2-minute job. But yeah, so that means the compiler and your program actually understands the types that you're working with. Absolutely great. So yeah, that's kind of good for me. And again, I said it pretty much solves serialization for me. Well, string serialization at least. And serialization is pretty much a solved problem. And this just makes it a little bit easier. And C++, this is a pain. You'd have to have your own preprocessor or some other craziness going on, but who cares? So that's done that crazy introspection. Let's go on to the complicated part of the topic. I'm running this and there's nothing done. This is the complicated part of the talk, which explains a bit of explanation. Before I've got that, Will is asking the question, he says, can I do %.2f sort of thing? You can if you implement it. I haven't implemented that in the printf stuff, mainly because I don't need it at the moment. But you can implement it. Again, it's just a software feature. It's not a hardware. It's not a compiler level feature. You can implement that if you want. So if you want a C style printf, go ahead and do it. Personally, I don't think that should be the best way of doing it, but I think the formatting should be done per element wise, but I don't know. I have to think about it. There's a lot of, that's just a library feature, not a language feature. So good, let's get on to the complicated thing, which is namespaces and files. So let's get down to it and here. So one thing I've been having that's a problem in C, and pretty much most languages in my opinion, is modules and kind of files and namespaces and all that lot. And it's very hard to get right. So in C, you include files. And what an include does is actually includes all that text of that file into that file. So it doesn't really care about namespaces. Everything's pretty much flat. C++ came along and said, yeah, we're going to implement this new keyword called namespace, and you can do your own namespaces. But it doesn't really solve anything, because in C++ they're not very useful, really. And it doesn't really solve a lot of problems. Like, a lot of the problems what you get across with having these imports and namespaces is there's a lot of collisions coming along still. And sometimes you don't want some things, like some files, accessing different things. You want to think like locally about a problem. And a lot of the ways to get around this, they think, no, you need to group header files and source files and all that crap, and do separate build compilation units. It gets crazy. So a lot of languages out there actually say, no, we're going to add something called modules or packages or something like that, which solves this. Now the problem is, a lot of languages, I think, overcomplicate this, and it's not easy to like reason with. So one good example and bad example at the same time is Go. So Go has something called packages. What you do is at the beginning of every Go file, you write package and the name of the package. Now I think this is very good, because then all you have to do is like import whatever package you have, and you say you want this package imported, blah blah blah. Now there's a few problems with this. How the package system works is that every file within that certain directory should be part of that package. If it's not a part of that package, it's a completely different program. It's not part of that program. This makes any sense. So, and also, every file within that package gets implicitly imported to one another, so they can access all of the stuff between each file. But because of that, all packages are kind of structured in a they're kind of mapped to your directory, which is very difficult. So there's no diagrams here, and this is all explanation. It's not easy to explain on paper, and that's one problem. And the other problem is in Go, it requires you to do what's the best way to put it? What's the other thing? Not relative paths, but absolute paths. And to me, that's really annoying, because sometimes, yeah, you kind of I like absolute paths, but a lot of the time I just want to do relative. Like, can I get this file in this in this directory, please, or the direct subdirectory? Like, no, you can't do that. You have to import the entire and it's like, oh, like I only wanted that little bit. And it's, in my opinion, it's also not easy portable, because how Go works, and it's just confusing. So I don't like that. There's other systems that do it, and a lot of them kind of get that halfway, and then they get circular dependency problems. So you can't import one thing, which imports another thing, which imports another thing, and imports the original thing. It'll say there's a circular dependency problem, or it'll go kaputs, and like, okay, that's not useful. Or sometimes, again, there's loads of problems here. So it's been spending months on, well, not months, it's like weeks, sorry, I'm getting the wrong time scales. I've been doing this all day. I said something we've been saying, it's like, took 14 months. Like, no, it took 14 weeks. Like, I've been doing this for a few weeks, and I've been trying to figure out how to do modules. And the way I've kind of solved it, in my opinion, like, I think I've solved it for most of my needs, and I think probably a lot of people's needs as well, is get rid of the concept of a module, is the short answer, and then it makes everything a lot simpler. And get rid of the concept of manual namespaces like in C++. That makes it a lot simpler. So what are we left with? Well, I already had this philosophy with the using thing, which I nicked from JEI. A lot of the ideas are nicked from JEI, but the using thing kind of says everything is a namespace. Everything. So your structures, your variables, everything, your types, everything are just namespaces, and you can import them into another namespace. You just use them in that other namespace, and that's quite nice to do. The problem is I thought, wait, what else could we make everything namespace? And I thought, why don't we just make a file the namespace? So I've done that. A file is just a namespace. That's all it is pretty much at the end of the day. And what you can do is import other namespaces into there. So I'm going to do is import test. Yeah, so this is it. So I'm going to say import and then the file name. That's all it is. Now I'm going to go to this test directory because it has all of the other types of imports there are, because there are 1, 2, 3, 4, 5 different kinds of imports you can do. The first one I'm going to show you is the most common. What this does is you import this file into this namespace. And you can see, and by default, it gives it a import name. So the default import name will be the name of the file. So fumpt in this case. If you want to be explicit and change the name of the file to, you want a custom one, so you don't want to be fumpt, I'm going to call it format, you could do, and you can do it explicitly there. We're going to call this thing every time here, by the way. So test dot thing, and we should get the same hello every time. So I'm going to do hello 1, 2, 3, 4, 5. So you can see we're on number 2 now. So you can be explicit with your own import name. Now sometimes you think, actually, I don't want to keep doing a referring to it this namespace. I just want to import all of the elements, or all the entities in fact, of that file into, file level entities into this file namespace. So you can do that with import as dot. So this is kind of saying, hey, just put it into this global namespace for me, please. Just do that. And you can see this, it works. So I don't have to refer to as .fumpt. The thing is now just print line. That is very useful. And the last one, which is a bit weird to a lot of people, all this does is, I kind of find the idea from Go, is just actually don't import any of the entities. Just give me the side effects, which may sound bizarre, like what the hell? Well, because I allow you to initialize variables in the global scope with actually just procedures and stuff, this means you can actually call some like side effect code, which is maybe good for like driver stuff. Maybe you want to initialize stuff already set up, but you don't need to use any of the functions in there. Like, that's very useful to have. Like, just import this file and give me the side effects of what happens. So this means pretty much build it, but don't do anything with it. That's what I'm kind of saying. And if I uncomment that, I should get print hello for, oh, that doesn't make any sense. Yeah, because what I've got saying here is this is undeclared. So you can see here it is undeclared name print line. It's never actually got imported. And to prove it, the underscore is my blank identifier. This doesn't work either. Like, underscore cannot be used as a value type. It doesn't work. It's called the blank identifier. Oops, keep doing that. So there's that. Now, these all seem weird. And I've got another one here as well. I'm going to keep explaining it. And this one may seem like, why have you added this? This seems stupid. So now there's another one called load. And what this does is very similar to import as dot. And this loads all of the entities into this file namespace. So my question is, what your question must be, is what's the difference between import and load? Well, the difference is, if I import this test file here, right, I should get, with an import, if I just use import here, I don't get any of the entities. The entities that have been imported don't get exported in this file, if that makes any sense. So the entities that are imported don't get exported. If you load those entities into that file, they do get exported. So let's start with the very first, this one here, to make it a little bit more explicit. Entities that are imported, including format here, I can't go format dot print line here. This will say undeclared name dot format. That says, oh, that's not been imported for me. Just make that clear, that's not been imported. Okay. Let's do another one. Let's do the dot thing. So as we know, print line's been explicit here, so we're going to test. Actually, no, that's been me even numpty. Let's go to test.format.println. And what it'll say is, just hide that. I think I'm going to hate this inline stuff here. Oh, I've got a compiler bug. That's not good. Oh, whoops. That's not good. That shouldn't have worked. But what it really should have said was, what it should have said is format has not been exported. That's, whoops. That's a bug in my compiler, so sorry about that, guys. It doesn't matter. That's the code generation part. I cocked something up today, doesn't matter. Let's do another one. So we import everything into here. So if we do this and hide that, oh well. What we get here is this is print line is not exported by test. So even though we've imported every entity from in the file level from funct into this file, this test, those imported entities do not get exported. So, okay, that makes sense. If I do want them to be exported, in many cases you want to, like you have like a base file and you have multiple like sub files for your module, if you want to call it that, then that is very useful in many cases. So if you want to do that, use load. And as you can see here, load works perfectly fine, because this loads all of the entities from that file namespace and exports them as well. That's what it does. And I very much like that. So that is kind of how I've solved it. So this is kind of how I like to think of things, and I kind of want to think locally as well. The reason why I'm doing this here is it's kind of thinking locally about problems. And a lot of languages don't really do that. They kind of either import everything or they don't import things. It gets a bit complicated. And another thing is I can load a file which loads another file which loads itself, and it would work perfectly fine. Like I could probably load the same file into here, but there's no namespace collisions because it says, actually, I've already imported these. I don't need to import them again. Like this is the same file I'm importing. So there's no collisions being imported going, which I think is great. So let's just close this down and not worry about it anymore. So I'm going to go to a little offshoot. It's going to Milton. Where is Milton? Here. And I've got a little diagram here to explain how things work and how we think locally about things. So first is a little graph, and these are different types of scopes you've got. So the bottom level scope are the declarations. So these are like the file level declarations, such as procedures, types, variables, constants, whatever. Those are what they are. Now, when you're searching for stuff in your scopes, like does it exist in this scope? No, go to that one, blah, blah, blah. Scope rule is very simple. You go to the parent scope and you look to your parent. Like, is it defined in this parent scope? So if you're inside a procedure and you're looking for a variable that's not defined in this procedure, you look to the parent scope. In this case, it would be a file scope, and you keep going to the parents. Now, this means if you have like siblings, so sibling things here, you cannot go up the stack, up this like tree, and then go back down. You must follow the arrows. So if something's declared in one like declaration, but it's not declared in this one, you can't access it. That's how scope rules work in most languages. Things like lambda calculus and stuff like C and C++ follow this as well. So yeah, it works. The thing that I'm doing differently is, you can notice is this bit here. So what I've kind of done, I don't know what the mathematical terminology is, I have something called shared global scopes, is what I have. I'll show you where I use it. And it's kind of like a spouse. So you follow the arrows and you go up, and it says, well, is it in the global scope? No, but we have a shared scope here. So we're dot, 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 dot. Is it in this scope? Yes, or not, we can go back. Once we've gone to that, we can keep going back, but we've already visited the global scope, so let's go back up. So the rules are, my simple things are, is you can only follow up. You can have other files here as well, by the way, like so. You can only follow the arrows up, and if you visit that node, you must go to its parent. Hopefully people are following along with this, because it is a weird scope rules, but it makes a lot of sense. Now you may be asking me, why don't I just merge everything, all the shared global stuff into the shared global stuff into the global stuff? This is where the imports come important. When you import things, they're local to that file. So if you imported everything into the global scope, which is maybe like a file, then all of these like children could access all of your imports. which is a bit crazy, and you don't particularly want that. Like, you want to think locally, you don't have to stupid that. So these shared things are that. They actually are, hey, we're sharing this scope. You can get all my exported entities, but you can never get any of my imported entities, if that makes any sense. And that's great. So the universal scope is where all the basic stuff's done. There's the global scopes for the runtime, the files are for you, and the declarations are within your files. Hopefully this diagram makes a little bit of sense. I tried to keep the rules very, very simple, but this is kind of how it works. So I'll show an example of the shared global scope in action and why it makes a lot of sense. So we need to go to the runtime for this, and this is where I use it. It's the only place I actually use it. And you notice that here it's got a little directive called shared global scope. And in shared global scope, what it says is, hey, this is every file can access this, but you do not want to access any of my imports and stuff. But you could access my loads if I had loads and stuff, yeah? So this is it. Every file can access this because it's all part of the shared global scope. But again, I don't want you accessing my imports. That's why I've got it. You're thinking locally about a file, and this file can only look through those bits. That's why I kind of like this idea, and it's quite nice. And I think for me, this solves most of my problems, with like virtually all of my problems when it comes to namespace and modules. For library writers, this would be very, very useful. For even myself, it's good. Like, I don't have to worry about I don't have to force my module structure to my files and directories. I can do it in whatever order I want. Well, I think the file itself is the lowest level you should actually like organize things in, like that you should force organization into. Like, I can organize all the entities in any file I want or any order I want and stuff. Now, I hope people are understanding this. This is, I don't know if any other languages do it similar to me. Again, I don't know actually how most languages do their module systems. A lot of them are complicated. I've looked like Rust and D and Go. Rust is really quite complicated. They even have explicit modules like C, like they're like nested modules you can do explicitly. I don't want them. I don't think they're very useful, personally. And I think probably per file is a better way of thinking of them, conceptually wise. Again, opinions here and there. Everyone's different. So there's that. Hopefully that makes a lot of sense. I think that's all I need to talk to about for the namespace stuff. What are we doing for time? Good, we should be done by before an hour. That's hopefully good. So let's go back to the demo and back to the demo here. If you've got any questions, please ask. It's quite a weird concept. Let's go to the miscellaneous stuff here. So there's a few other miscellaneous stuff that I need to kind of talk about. I've added some extra things here for like linking and stuff. And so there's the DLL import and DLL export. So if you ever worked on MSPC or whatever, you'll notice that a lot of the Win32 stuff have this imp prefix to it. And the way you do that is you kind of prefix with your procedure declaration with DLL import. So if I go to the Win32 file, which is this namespace here, I can you can see everything here. So the wrapping's gone crap. Here's another one. Like, it's a foreign function. That's it. Using the foreign function interface, and then I'm saying it's using DLL import on it. So that's the kind of the core link stuff for me. You can also say you can change the link name stuff. So in the source, this will be mangled. So if you look at the actual like generated code, and I look for I can't even spell miscellany. In the code, you'll notice it's got a dot at the start. Or in some of in other cases of other code, they'll have like a prefix and stuff. And this is because I don't want to get around. Don't want to collide with like the C runtime library and other functions that have none. Like if I want to look for a name, here's the one here, it's like llvm.memset or stuff. That's another one. Let's look at one of mine actually. Let's look at here. .funct-2 $$ is digit -0. Like what? This is like a weird convention that I've got going on, like name mangling. So you wouldn't want to call this, and it's actually semi-pseudo random, that is, as well. So it's not very useful. You couldn't call this reliably. So if you wanted to make sure that this function was that way, I'm going to say change the link name, and I call it, I would say Bob. So in the source, if I search for Bob, you can see it's now actually going to do that. So if you were doing a DLL, you'd be able to call this procedure by Bob and link it that way. It'd be great. And if we change it back, it should go to miscellany. There you go, it's brilliant. And sorry for my dreadful code generation, it is just naive. The other thing is I can change the calling convention. So some functions, especially within Win32, will have different calling conventions. Like they may have standard call, which is standard call says, hey, it's kind of like normal C calling conventions, but we don't support variadic functions. So I could probably do this for all of mine, and also standard call does it backwards, so the last entry gets inputted first, I think. And I think with this thing here as well, there's also fast call, there's another calling convention, where it puts the first two arguments, if it can, into registers. Or if I remember that correctly, and the rest are all on the stack. Now, I'm thinking if I don't allow like C-style variadic procedures, and mine are all just kind of implicitly structures that like slices that I pass. I'm thinking, should I change the calling convention and have my own custom one? Like I could use one of these or something else and increase. I don't have to worry about the variadicness or anything. But if you want to be explicit, you can do it yourself. You can add the C calling convention or whatever. And again, I've already talked about the global runtime. So there are some other things I've added, and I don't know if I talked about these in previous compiler demos, can't remember exactly. Is assert, compile assert, and panic. So assert is a runtime assert. And, oh, does miscellany actually get called? Yeah, it does. That's broke. Let's go to the compile time assert. There we go. Compile time assert. Time assertion was false. Why is assert not working? I think I broke something in the runtime. And then panic should work as well. There we go. Panic works, but assert doesn't. So let's say assert true. Whoops-a-daisy. I know what I've done wrong. Yeah, I don't think this is going to work. There's a bug. Sorry about that, guys. But panic will work. With this is kind of like assert true, assert false with a message. That's all the panic is. That's a bug. Whoops. Oh, it doesn't matter. But that's kind of the implementation of what assert is. You just go past the file line column the message, and then just do a debug trap. That's all it is. The message is probably the expression. So that's all I've kind of got to talk to today. But the other things that's all I've kind of implemented in today's compiler. I've done that in less than an hour, thank God. Hopefully people understand me, and if you haven't, please ask questions. Prefix it with Q: in the comments. And yay. So the next things I'm kind of going to work on the compiler is I'm going to work on build systems. I've also got to work on concurrency systems as well, like trying to embed a lot of that into the language. And the most important thing is metaprogramming. So I need to get a lot of compile time features, generating new code, getting metaprogramming at the end of the day. Very useful. So I think it's now question and answers time. So let's go to Milton and write Q&A. So thank you all for watching so long. If you stay tuned after the recording, there may be a surprise for people who are watching on stream. Hint, hint. So I'm just going to get a breather to drink and stuff, so I'll be right back in a few minutes. In a few minutes. There we go. Sorry, I just had to get a drink break from my throat, which is a bit fun. So I just quiet down this bed because it's a little bit. It's good, but you could probably get fed up at the same song every time. So let's stop that, and great. So let's get the questions rolling. So there's some old questions I haven't answered yet. So non-sensational's got a few. Some of them. Will you ever do a stream on how to generate the LLVM IR from the ST? Probably. I could probably show you some of the implementation now, but what I do is it's kind of how most compilers work. You have a tokenize the code. You turn all your files into tokens. Then you pass the files, which turns it into an AST. You then pass this through the semantic checker, which will generate all the symbol tables that I need. Then I pass the symbol table generation and the AST to the code generation part, which is the intermediate representation. Then this means it's got all the type information. I can just generate it and map it to the intermediate representation. I don't use any of the LLVM tools. I've made my own mainly because on Windows it's absolutely dreadful. I also find the tutorial on the LLVM website not decent at all. It's very hard and it's very I couldn't understand it. I couldn't understand. I know it sounds. I might be like, saying idiot. I couldn't understand what they were trying to do. I find it easy just to print out, pass C in and see what it generates. And I learnt that way, and I kept learning from the spec and reading that way how LLVM IR works. So that's the first question you asked. There was a few other questions you asked. So is it possible to reorder them, like when you do the structure reordering, reorder them for considering the hop variables be at the top? So like ignore the ordering of it. And I think probably that's not a bad idea. Like saying, hey, please ignore the ordering of this. This has got higher priority than others. And I think that's probably a good idea. Like you could say, hey, this parameter here is ordered, while the rest are not ordered by default. I think that's probably a good idea. I'll write that down. Override override auto rearranging. I write down notes on paper all the time. That's how I do most of my remembering. Some other questions that's going on. What was the other one? Well, there was another one going on there, yeah. But again, if you do want, I probably may do another video about explaining how the code all works. There's not many questions today. I hope people understood a lot of stuff. But yeah, a lot of what I've implemented now is kind of precursor stuff for what I need to when I go do the metaprogramming stuff. For me, this actually solves a lot of my problems already with metaprogramming. But there's a few things I need to implement. Again, metaprogramming, and you see like parametric polymorphism is the technical term, so generics is what most people call it. And it's a silly term in my opinion. I think all of them are silly terms, but like, hey, here's a generic data structure, like stuff. I don't think many languages do it well, or even the way you like, because it's usually like a second language on top is the problem. And I've got to fix that. There's a lot of things going on there. Oh, for people who are here, I forgot to show some of the trick demos. So to show these modules in action, let's go on to the HTTP test. So let's get up a web browser, like so. Here's a web browser on the here. Let's just how do I Alt F11? I can't remember actually how to get out of flipping this. That'll go. It's close enough. So what I'm going to do is the HTTP test. So we're going to run this. I'm going to run that, and hey presto, we've got a server running. There's a HTTP server running this code. So there's one little demo, just to prove this. And this all I'm doing is importing, showing that import's working correctly. And here's all the. This is WinSocket stuff. It's an absolutely crap demo. This is all I write to do the demo. So if you look at the view source, that's what it looks like. Nothing special, but it works. So that's that first demo. The second demo is that old game that I showed off ages ago. That code still runs, and look, this is one of the first demos I did. This all still runs, but absolutely fine. I haven't even done anything to it really. Just changed some of the import stuff just to make it working, but that still works. Lovely jubbly. Another thing a little project I'm started working on is porting Martin Cohen's Punity to the language. So here's a little demo. And here you go, this is absolutely nothing special, but it's 128 by 108 bits, and it's fixed to a frame rate of 30 frames per second. But again, Punity is a little library which I absolutely love. It's very simple, and let's find it. Here it is, for people who want to see. It's again a tiny game engine in C, and it's kind of meant for just like making quick code. I need to implement this in my language pretty much. I also need to kind of do minor ports of the STP libraries and stuff as well, because that'll be needed stuff. The first thing I'm going to do, I'm going to probably start now, because I think the compilers are far enough and along to actually do this. So what I'm going to be doing is what was I doing? Yeah, sorry, I'm just thinking out loud now. What I'm going to be doing now is implementing making a game, like a mini game or something, or even, I'm not sure if game or a web server is what I'm trying to think of doing. Which one's probably more of a complicated thing, but yes. As Will was saying, yeah, the metaprogram is pretty good stuff. Yeah, it solves a lot of my problems with C. I can do type of the value, I can do the introspection stuff. This solves like most people's problems with metaprogramming, but not all of them. And it doesn't solve all of mine either. But because there's some of them, like I want to kind of not add language constructs, but kind of want to modify them. Now I know there's like nim. I've looked at nim, and what that does is a lot of that is you can actually add new constructs. And I know there's some other languages like Elixir and stuff, like the entire language is pretty much just macros. But my problem with like those languages, like nim, is got optional garbage collection, and I don't really like nim. There's a lot of stuff in it that I think's a bit dodgy. Sorry, and also I don't think you can change it because it's like the fundamental language design and the syntax is all wrong. But yeah, that's kind of work. And again, what I was going to say, this is the whole point of this language is to stop me doing the stupid like preprocessor stuff for C. This is one of the main reasons what I was doing. I was creating so many preprocessor languages, preprocessor programs to process C, so I could get all the metaprogram capabilities and all the introspection stuff. And I still have some of them I'm using, but it's not worth it in my opinion. It's just better to make a new language and start right at the right from the beginning. So there's that. So there's some of my little demos, and thank you all for watching. I know this has been actually about a reasonable length stream. I tried to keep it short, and hopefully I haven't under-explained things or gone too quickly or anything for people. So thank you for all watching, and the people who are streaming, stay tuned.